school on time. I feel like oh, that one I think I did good. I'll show you. I think I did good.
What was the average for a class?
I would have to look at it.
I guess 76.
Asia?
I don't know if break the formula down.
I don't want to like, it's not okay.
Oh, I'm actually smart.
Oh.
Instead of putting nothing, I actually put something about.
I just said that.
Oh shit, I got that one.
Yeah, it was this one that
I always got everyone right. I had this working now.
Oh, wow.
Yeah, see, I didn't prepare on
Today's bonus, we'll see.
I
think
Alright.
Well, yeah, no, I know. No, but we're trying to see
Yeah, I got something like that.
Listen, I did all together. I'll tell you, it's probably
Hey.
Oh,
I swear to God, I didn't read Hey, hey.
I got this one. This one. I did not
The average was a 42%. Or no, I'm sorry, 42, a 60%.
Oh, okay. Oh, wait, oh, it's probably. You barely see it.
All right, so here we go, ladies and gentlemen. First question worth 5 points, ladies and gentlemen. For the masses, first of all, the formulas you were supposed to use was the density of A over the density of B is proportional to the mass of A over the mass of B. Then you were supposed to use the formula masses, ladies and gentlemen, for the two gases that were in the problem. One was fluorine gas, which is F2, one of the diatomics. Formula mass 37.996. The other one was carbon dioxide, CO2, 44.009. We set these up on one side. We set this up on the other. When we end up solving, we end up with 3.33 grams per liter, ladies and gentlemen. Questions?
So, what did I get wrong here? Because you said 6 figs, but I had it.
Do you have it in 3 sig figs?
Yeah.
Let me see. Let me see. Okay, put a note on it to check number 1, and I will check it again. All right, number 2, ladies and gentlemen, you were finding the density of a gas, but this time you were not given the second gas. This time you needed to find the density, and there were 2 basic ways to do it, ladies and gentlemen. You could have used PV equals nRT, or you could have used combined gas laws. I chose to use PV equals nRT. So first thing, ladies and gentlemen, you need to figure out what carbon tetrachloride is, CCl4. We need the formula mass because if we are going to find the density of any gas, we need to find the formula mass and use it for the mass, and then we need to find the volume under its conditions. So density is mass divided by volume. Formula mass 153.881. PV equals nRT. We put in our pressure. We put in 1 for the mole, 1.21 for the PSI, and in Kelvin that comes out to 277.33 Kelvin for the temperature. We solve for V, we get 21.2 liters. We take the mass of 153.811 divided by 21.2, 7.26 grams per liter. Questions? All right. Question number 3. Gave you 41.1 grams of oxygen under a pressure of 1.00 atm, a volume of 39.6 liters. What would the temperature of the gas be? This is in grams. What do I need to get it into? I need to get it into moles. So I'm going to need the formula mass here. You cannot just plug the mass in here, and you cannot assume 1 mole because it's telling you how much gas is here. So when we do this, we get 1.28 moles of oxygen gas. Now we can put it into PV equals nRT. Pressure, volume, moles of gas, our R value, 0.0821. Solve for temperature. Temperature is 378 Kelvin. Subtract 273 from that, ladies and gentlemen. That means your gas is at 105 degrees Celsius, 3 sig figs there. Questions? We calculated about 3 or 4 R values in class. I even made up Chris Brand's made-up unit, CMBU. Had you calculate what the R value would be for it. So, ISPs is just a made-up unit, ladies and gentlemen. Okay? Gave you a pressure in a made-up unit. You needed to use 22.4 for the volume. You needed to use 1 for the moles. You needed to use 273 for the temperature in Kelvin. You solve for R, 3.20. ISP times liters over mole times Kelvin will equal that R value. Questions, ladies and gentlemen? Excellent. Wonderful. Probably the hardest one on here was number 5, ladies and gentlemen, because it required you to do the most work. Okay? You have a mixture of 4 gases. They give you the partial pressure of 3 of them, which means you need to use this formula here to find the 4th. P of A plus P of B plus P of C plus P of D equals the total pressure. I had all but P of A, so when I solved for P of A, I got 192.3 millimeters of mercury. This is not my final answer, so I don't even need a unit by it. Okay? This does not need to be in sig figs. It's not my final answer. I plug it into this formula because I know the moles of B. What I don't know is I don't know the mole total. So I put the moles of B in here. I solve for the mole total. I get 6.11 moles. Now I can go back and I can use this formula, putting in the mole total, the moles of B, moles of A, or the pressure of A over the pressure total, and I can solve for the moles of B in a fairly easy method. Now I do want to show you one other thing you could have used if you understand math really well, ladies and gentlemen. What we're saying in this problem is that the pressure of a gas over the total pressure is equal to the moles of a gas over the mole total. Well, we could have also done this. The pressure of gas A over the pressure of gas B would be equal to the moles of gas A over the moles of gas B. And we could have plugged in for the pressure of A, the number that we got, 192.3, over the pressure of gas B, which was 435.0 millimeters of mercury. And you could have set it equal to the moles of A over the moles of B, and you could have done it in one step, ladies and gentlemen. Just another possibility for you. You solve this, you're going to get that same number. Question? Because all this is a ratio. And in this mixture of gases, the pressure of any gas compared to another will be equal to the ratio of the moles of that gas to the moles of the other. Could have done it that way if you had wanted to. Okay? All right. Number 6, ladies and gentlemen. How many grams of sulfur dioxide gas are present in a sample with 598 milliliters at a temperature of 48.5 degrees Celsius and a pressure of 580 psi? This one and question number 3 are kind of the opposites of each other. In number 3, I gave you the grams and asked you to find the temperature. Here I'm giving you the temperature and asking you to find the grams. Put it into PV equals nRT, but the milliliters we've got to convert to liters. The temperature we've got to convert to Kelvin. Now I put everything into my formula and I solve for N. Now it is not unusual to get a really small amount of gas. So we get 0.00892 moles. Now, because it's sulfur dioxide gas, I need the formula mass over 1 mole, and then I can get the grams of sulfur dioxide gas. In the end, 0.571 grams. Questions? Okay, that was the first half of the test. The second half of the test was no math. It was all about you understanding the concepts and the ideas that we had been talking about. So, ladies and gentlemen, the weather balloon question. Okay? Now, one of the things that you need to understand is, one, you need to know how to read a graph. What's happening to the temperature in here? Really? That's dropping. What? How do you know it's going up? Well, where's temperature on your axis? Okay, so from here, minus 50 degrees or minus 55 degrees, to here, minus 5 degrees, is that going up or down? Okay, so temperature is going up. We said that the amount of air particles hitting on the outside of the balloon is getting less and less. If there are fewer particles hitting on the balloon, what is that going to change about the balloon? It's what? What? Yeah. Again, the particles hitting the outside of the balloon will generate what? Which of these 4 things? Pressure, temperature, or amount of gas? Pressure. If fewer particles are hitting on the outside of the balloon, what does that mean for pressure? Really? So when fewer particles hit on the outside of the balloon, the pressure is going up? It's going down. Fewer bombardment. Pressure is going down. Temperature is going up. The balloon is sealed, right? What does that mean for the amount of gas? It can't change. If this doesn't change, it can't have any effect on volume. If temperature goes up, volume and temperature are in a direct relationship, volume would go up. Pressure and volume are in an inverse relationship. So if pressure is going down, what's that going to cause volume to do? Go up. So ultimately, what causes the balloon to explode? The pressure and the temperature, which are both trying to increase the volume. Questions? So you got 1 point for each of these arrows. And 2 points for telling me the temp going up and the pressure going down will cause the balloon to burst. Questions? All right, what unit must temperature be in? Kelvin. Why? Because you can't have negative numbers, and it is the only way that the relationship in gas law holds. It is the only way that the gas law relationships will hold. If you do your problems in degrees Celsius, they don't work out. The table down below. Avogadro's relates volume and amount of gas. Pressure and temperature held constant. It is a direct relationship. The only inverse relationship is Boyle's law, which relates pressure and volume. The constants are temperature and amount of gas. If V and N are constant, P and T are the ones that are being changed. If P and T are being changed, that is Gay-Lussac's law. That is a direct relationship. If V and T are being changed, P and N are constant. That is Charles' law, and it is still a direct relationship, ladies and gentlemen. Questions? Yes?
Like back to the unit we like to have, where you said Celsius, if it's like calculated in Celsius, it would work out, right?
It would not work out. No. Well, think about this. Correct? Gas law, right? If this number doubles, what has to happen to that number? Has to also double, correct? All right, what's the temperature outside today? About 28, okay? And that is Fahrenheit, okay? In Celsius, that would be just below 0. So let's say in Celsius, the temperature outside is 1 degree Celsius today. If tomorrow the temperature were 2 degrees Celsius, what has our temperature done here? How much? No, it is doubled.
Oh.
From 1 to 2 is a doubling, right? What would that do to the air pressure around us? Double it. Now think about this. If we went from 1 Celsius to 10 degrees Celsius, what is happening to the temperature? It went up by 10. What would happen to the pressure of the air around us? It would go up by 10 times as well, right? But this is 274 Kelvin. This is 275. Is that a doubling? No. That is only a slight increase, which means pressure will only slightly increase. Even here, that is not a 10 times increase, is it? If gas laws worked on Celsius, at the temperatures we live at, we would be crushed by the pressure of gases, because when it's a average temperature inside the room here, it's 20 degrees. Outside, it's 1 degrees. That is a 20 times increase in pressure in this room compared to outside. We couldn't handle it. But in Kelvin, it's just a slight change. That's why you have to do them in Kelvin. Questions? Okay. Now, I had given you this question on a quiz earlier, ladies and gentlemen. And yet I still had people who can't tell me what pressure is. Now, I accepted 2 definitions: the constant bombardment of particles on the walls of the container and the amount of pressure applied to a certain area. I accepted any one of the 4 units: mm, Hg, psi, kPa, or atm. Volume is the amount of space something takes up. That's what volume is. The amount of space something takes up. It's in cubic centimeters, milliliters, and liters. Temperature is the average kinetic energy in particles of matter. That is the definition of it. Symbol, or the unit, is K. I also accepted degrees Celsius. And finally, ladies and gentlemen, N is the amount of substance, the number of particles that are there, and it is measured in mole. Okay? If you define chemistry by telling me the science of the study of matter, its structure, its property, its composition, and the changes it undergoes, you got 3 bonus points. That was an easy one. That one you should have had. Name what 3 elements make up what tired science teachers like to take. Nitrogen,
What did you just say?
wait. Sodium, sorry. I had the wrong one. Sodium, Na. Phosphorus, P, and sulfur. NaPS.
Oh,
NAPS. NAPS. That's what tired science teachers like to take. If you came up with something else, ladies and gentlemen, I would have given you credit for it. Okay? If you could have found a way to do sleep, okay, go for it. And finally, ladies and gentlemen, which is correct? 8 and 8 is 15 or 8 and 8 are 15? Neither. 8 and 8 is 16, not 15. So neither one of those is correct. All right. So if you have an error on your test that I need to correct, you need to take and you need to bring it up to me and put it on my desk by the end of the hour with a note on it that tells me what I am supposed to be looking for, just so that I know. So if the total is wrong, if the number, if I graded one wrong on a page, whatever, you need to put a note at the top. Please, by the way, double check my arithmetic. I do not use a calculator when I add up the points in the corners to get the point total on the front. So if I have made a mistake, you need to check it and you need to let me know. Okay? Questions? Okay. This is the unit, ladies and gentlemen, that we have been working towards all year long in this class. This one unit that we are going to do now, ladies and gentlemen, is a culmination of everything that we have done in every unit so far. Your final test, ladies and gentlemen, for this unit will have on it 4 to 6 questions. That is it. Each question will be worth between 20 and 30 points, though, because everything that we have learned is going into this. Okay? So, what you are looking at there probably doesn't make a lot of sense to you yet. But that is what the questions on your test will look like. There will be 4 to 6 of them. Okay? So, by the end of the unit, I better be able to explain and show you how to do these, and that's what we are going to start working on today. All right. So, I've given you that packet. Don't lose that packet. Keep that packet because we will be working on it throughout the unit. In Canvas, there is a new unit there for you, ladies and gentlemen. Ooh, maybe it is not there yet. Hang on. I'll bet you I haven't made it published yet. Hold on. Modules. All right, so I just published the module and all the units, which means you can now find it, ladies and gentlemen. Please open up the Unit 7 Student EISN. That is your notes for this unit, okay? Here are the answer keys for the worksheets that I just handed you. Here are the notes that I'm going to show you that we are going to go through. So again, once you open up the Unit 7 EISN, ladies and gentlemen, I would bookmark it. I would get rid of the bookmark for the Unit 6 one. I would make it easy for you to find it and easy for you to access it. By the way, I gave you a grade report, ladies and gentlemen. The grade report has everything that we have done so far. Now, you're graded on here on 3 things so far. quizzes, labs, and tests. So if you are missing something from there, that's going to make a big deal on your final grade. You need to start making the things up that you are missing. Some of you are missing quizzes, some of you are missing tests, some of you are missing labs. You will know that because it will have an M next to the score and a 0 for it. And that's what it's counting as, is a 0. So, ladies and gentlemen, again, I am not chasing your butts around this school and going, hey, you got to make this up. Hey, you got to make this up. You are preparing to go to college in a year or two. This is a college prep type course. Your professor is not going to be like, hey, you missed the test day. You need to come in and make it up. You need to make a time when you are going to do that. I have given you a list of anything that you are missing. It's your job to figure out when you are going to make it up. If you need help making it up, I am here every day before school except for the last day of the week. I am here after school almost every day. There is a tutoring lab up in 309. If you go up there and I am not there, they will send you down to my room and I will help you here. And ladies and gentlemen, you can come in during advisory anytime you want and get help during that 25-minute time period. Other than before school, after school, and during school, I don't know when else you expect to get help. Because those are the only 3 times that I am available. Do not ask me to give up my lunch hour. Look at this body. I don't skip lunches. Okay? So, questions. If you think there is something wrong on that grade report, if you turned in one of those things and I don't have a grade for it, you need to let me know. Send me an email. Stop by after class and just say, hey, Mr. Brand, I think I did this lab. Can you check? Everything is done online. I can go in. I can check. Easy to find. Okay? Questions? All right. This unit, ladies and gentlemen, is on a topic called stoichiometry. That is a big, long word. Here's what it means. It means that before we ever go into a lab and do an experiment, we should be able to figure out exactly how much stuff we will create in a chemical reaction. If you start out with a certain amount of these reactants at the beginning, stoichiometry says we can figure out how much we are going to create at the end. Now, when you create something, ladies and gentlemen, you may create something that is a solid. How would we measure a solid? What unit do we use to measure solid objects? Powder. A chunk of metal. How would we measure it to begin an experiment? What are those? What are those things on the end of the table, ladies and gentlemen? Balances. Scales. Balances is a better word. What unit do they measure in? Grams. So you may be given information where you start out in grams. Now, what if the substance is a gas? What are you going to need to know if it's a gas? Come on, just finish this unit. Took the test yesterday. What do I need to describe about a gas to you? 4 things. What? Volume, temperature, amount of gas, and pressure. So guess what? We're going to be using PV equals nRT again. Don't forget it. We're going to be using it in here. And the third way you can be given something in this unit is you can make something aqueous. Aqueous means it is what? In water. And we're going to show you how you can figure out or how we would measure things when they are dissolved in water. And that's one of the first things that we are going to do. But those are the ways you can begin with things in a reaction. Guess what? Those are the same ways you can end with things. You may create a solid that you can put on a balance. You may create a gas. Well, you need to know the pressure, the volume, the temperature, the amount of gas that you would create. Or you could create a solution, something that is aqueous. And we will show you how to handle that. Okay? Now, grams, we go back up to here. You better be able to get from grams to moles. For a gas, we know how to get to moles, but we need to use PV equals nRT. And for the last one, a solution, it's something called molarity. But again, you can get into moles. The key to working these problems is taking whatever you're given and getting it into moles. And then we'll show you how to use it from there. You start out by getting into moles, you get an answer in moles, and you end up coming out into the unit that you want. You want to go from moles to grams? We have a way of doing that. You want to go from moles to volume of a gas? We have a way of doing that. It's called PV equals nRT. You want to go from moles to a solution? We have a way of doing that. It's called molarity. Those are the three ways we're getting into things. Those are the three ways that we are getting out, ladies and gentlemen. Okay? So, these are the different things that we're going to do. First of all, I'm going to introduce you to the steps to STOIC. There are a lot of steps. We'll boil it down. We're just showing it to you so you have an idea of what we're trying to do. We're going to work on molarity first. It's something we haven't covered yet. Then we're going to do mass to mass STOIC. If you have so many grams of this at the beginning, how many grams of this stuff will you have at the end? Then we're going to do volumes of a gas to mole relationship. So if you have a pressure, a temperature, a volume, how do we get it into moles? PV equals nRT. Then we're going to do molarity problems. Then we're going to talk about something called the limiting reactant, because do you remember the last lab we did, the gas law? Where we took the acid, poured it into the tube, filled the tube, put the magnesium in there? The magnesium, we told you how much, well, we measured how much magnesium we used, correct? We put it on the balance. But when it came to acid, what did I tell you? About how much? 20. Did I tell you that it mattered? No. That is because acid was what we call an excess in the experiment. It wasn't going to limit our reaction. But what did limit our reaction was the amount of magnesium that you began with. And that's why at the end we compared the amount of magnesium in question 1 to the amount of gas we produced in question 3. And did our percent error calculation, because the amount of magnesium determined how much gas we created. Okay? We'll talk about ionic compounds in water, and then we will talk about ionic solutions. Net ionic equations, I'm sorry. All right, here are the steps to STOIC, ladies and gentlemen. Do not write these down. Do not copy them onto your yellow sheet. Okay? But this is what's going to happen. You are going to write a skeleton equation. In other words, I'm going to tell you that this reacts with this. You have to tell me what they produce. That goes back to Unit 4, ladies and gentlemen. You're going to have to write good formulas. That goes back to Unit 3. You're going to have to predict the products, part of Unit 3 and part of Unit 4. And you are going to have to be able to write states of matter. That will be given to you. So solid, liquid, gas, aqueous. You're going to have to balance an equation. We did that in Unit 4. Coming back again. You're going to have to use coefficients to get the same number of atoms on each side of the equation. Then you're going to have to get organized. What are you given? How much of this reacted? How much of this reacted? What are you looking for? Because you're only going to look for one product. You're going to look for one thing that is created. Okay? And you're going to convert what you're given into moles. And there are 3 ways you will be given it. You're going to be given mass that you will convert to moles using formula mass. You're going to be given volume of a gas that you're going to put into moles. You're going to use PV equals nRT. Or you are going to be given the volume and the molarity of a solution, in which case you take volumes times molarity to get moles. That's what we're going to start talking about in a few minutes. But either way, you take what you're given and you get it into moles. Have to. Then you're going to use a molar ratio. A molar ratio says if I have so many moles of this on one side of an equation, I'm going to create so many moles of something on another side. We will show you how to easily find that molar ratio and how to easily use that molar ratio. But it might be from reactant to product. This is normally the way it will go. But you could talk about if I have this much reactant, how much of the other reactant do I need? Or it could be if I create this much product, how much of the other product would I also create? Very rarely will we do that, but you could. And then you're going to look for something called a limiting reactant, something that you run out of. Because in a reaction, the reactants will make a certain amount of products. But you might have extra of one reactant compared to the other. So which one of the reactants do you run out of first? That is what is called a limiting reactant. Okay? One of the most common examples of a limiting reactant is when you go to the store and buy hot dogs. How many hot dogs come in a package? How many? 10. But how many buns come in a package? 8. So if you buy one package of hot dogs and one package of buns, what are you going to run out of first? The buns. That's called the limiting reactant. It is the one you run out of first. So don't invite more than 8 friends over if you buy one package of buns and one package of hot dogs. Because you're not going to have enough. Okay? So do you now buy 2 packages of buns? Well, that would give you 16, correct? Now what do you run out of first? Now you run out of the hot dog. Something always limits a reactant. When you limit or run out of something, the reaction stops. It can't go on anymore. We'll teach you how to find that. Then, ladies and gentlemen, once you know how much product you will create, you will either be asked to put it back into mass, in which case you will use formula mass equals to 1 mole again. You'll be asked to figure out what volume of the gas would be produced. You're going to use PV equals nRT, this time solving for V. Or you're going to be asked to find the solution, its molarity. We will show you how to do that. So let's get to molarity, ladies and gentlemen. Okay? First, we're going to explain what molarity is. Molarity is a term. What it means, or what it is it's the number of moles of solute per liter of solution. Okay? So I take some salt and I throw it into water. I can find the molarity of that solution. Now, you worked with an acid the other day. That acid was 6 molar acid. That means that in every liter of acid, there was 6 moles of HCl in it. But did you use a liter when you did the lab? How much did you use? Do you remember? Like 20 milliliters. So guess what? If you're using 20 milliliters and there are 6 moles in a liter, are you using all 6 moles? No, but you're using a portion of it. We can figure out what portion you were using. That's the way we measure solutions. We give them something called a molarity. It is a number that tells you how many moles are in 1 liter of solution. Okay? So, it is expressed as moles over liters. That is what molarity is. This is what the actual unit is. But we very rarely write it this way, ladies and gentlemen. We normally instead write a capital M. M stands for molarity. Molarity means moles per liter. People don't want to write this. This is easier to write. So, for example, if you have 3.25 molar sodium chloride, what that means is that there are 3.25 moles of sodium chloride in 1 liter of solution. And molarity allows you to convert liters of solution into moles. So again, we use 6 molar HCl. We only use 20 milliliters of it. We did not use all 6 moles. we used a much smaller amount. We will show you how to calculate that. All right. So, what is the molarity of an aqueous solution containing 40 grams of glucose in 1.5 liters of solution? Okay? So, our formula, ladies and gentlemen, is going to be this. I should have written it down. Molarity is equal to moles over liters. Okay? Now, what am I doing with this grams here? What is this that I'm doing to it?
Putting it into moles.
Using what?
Formula.
Formula mass. So again, here's the formula for glucose. C6H12O6. So, C6H12O6, 6 times 12.011 plus 12 times 1.01 plus 6 times 15.999. Formula mass, correct? Questions on that? That gives me the 180.18 grams of C6H12O6 that is equal to 1 mole. Questions on any of that? We're good? Okay. Now I'm going to use this to get out of 40 grams and into moles. Okay? Out of 40 grams and into moles. When I do this, this is what I get out of my calculator, 0.2200. Questions? All that is taking 40 divided by 180.18. Grams of C6H12O6 cancel out. I'm left with moles of it. Now, to find molarity, I have the moles. What's the liters of solution? How much?
1.5 liters.
So I'm going to take that number of moles divided by 1.5 liters of solution. Okay? And I am going to get my molarity. That is how we calculate a molarity. We take the moles of stuff that was dissolved by how much liquid we dissolved it in. This must be in liters. Has to be. Now be careful. What state of matter is this? Liquid. This is dissolved in water. So that is not the volume of a gas. We're not using PV equals nRT here. This is the volume of a liquid solution. Okay? This is the volume of a liquid solution. And what we have done now is we have used the moles and the liters to calculate the molarity. Questions? I'm doing this to show you how you're going to get those numbers that they may be giving you. That 6 moles, 6 molar hydrochloric acid, meant that there were 6 moles in 1 liter of it. Okay? That's what it means. All right? Questions on this? That's how we find molarity. Any questions at all? Okay. So let's take a look at our next one. Our next one, we have a molarity. 3.50 molar solution. We have a volume, 255 milliliters. What we don't have is we don't have the moles. Okay? So, here we go, ladies and gentlemen. This should all be on your slide for you already, but I'm going to go through it and I'm going to show you how we would do it. First of all, silver nitrate. I need a formula for silver nitrate. What is the symbol for silver and its charge? Ag. What's its charge?
+1.
I need a formula for nitrate and a charge. Nitrate is a polyatomic on the back of your sheet. NO3,
with a -1 charge.
-1 charge. Remember we do the crisscross method? This one comes down by the Ag, this one goes down by the NO3. Our formula is AgNO3. Okay? That is our formula. Any questions on that? Again, a little bit of reviewing for you because this has been a little bit of time, right? Any questions? Okay. So now, ladies and gentlemen, I'm going to again use this formula. Okay? I'm going to again use this formula. My molarity is 3.50 moles, or molarity. Okay? By the way, they would normally read this as 3.5 molar. Another way of saying molarity. It's a 3.5 molar solution. Okay? And it is equal to, now I don't know how many moles. That is what I'm asked to find. But I do know how much solution. How much solution? Well, just tell me first, Eric.
255 milliliters.
255 milliliters. Now, to put it in here, I do need it in what number? Or what unit? I'm sorry.
Liters.
Liters. So how do we get from milliliters to liters? Correct. We are going to divide by 1,000. There's the math to show you that we are going to do that. Which means this becomes what? And now we're in the unit of liters. I plug that in down here. Guess what, ladies and gentlemen? This is algebra again. This is algebra again. I'm solving for moles. What do I do to solve for moles?
Would you multiply 0.255?
Times what?
You
On which
multiply it
side?
On both sides.
Thank you. You're going to multiply it on both sides. Times. Now, why am I doing that? It gets moles alone on one side of the equation. What I do to one side of an equation, I have to do to the other. Okay? I have to do to the other. So, moles equals 0.255 liters times 3.50 molar. Now, hold on a minute. I'm now going to take this unit and I'm going to turn it into what it actually is. What actually is molarity? What over what? No, where are you getting mass? I've never given you mass here. Moles divided by liters. The only reason I'm doing that is so that we could see our units cancel here. Okay? This and this mean the same thing. They mean the same thing. Molarity means moles per liter. All I did was do this so that you could see that what's going to happen to liters.
They cancel out.
And what unit am I left in?
In moles.
Which is what I was looking for. So somebody take 0.255 times 3.50. Tell me what we get.
Uh, 0.8925.
Okay, 8925.
Oh, 3.
Thank you. Good. You jumped the gun. You got me there. I was going to tell you. Let's round it to 3 sig figs.
I just thought that it didn't matter because it wasn't going to be your, like.
Well, this is your final answer. How many moles?
Oh,
Okay? So this is my final answer. And my final answer is 0.893 moles
G.
of AgNO3. Questions? Yes, no, maybe so. So let me explain what we've done. First, we solved for molarity in the last problem, correct? Now we've solved for moles in this problem, correct? What do you think the next problem is going to make us do? And that's the only things that you could solve for. That's the only things that you could solve for. Now, could have asked for one other thing. What could it have asked for instead of moles in your answer?
Grams.
How would we have gotten it to grams?
With the formula.
We would have gotten it there with formula mass. Very good. It didn't ask for grams. I can stop here. If it had asked for grams, okay, AgNO3, 1 times the mass of silver,
107.
107.8. Is that what it is on your sheet, or is it 107.9?
No, it's 107.87.
87. Good. Plus 1 times nitrogen, 14.07.
007.
007. Thank you, Eric. And oxygen, 3 times 15.999. Somebody do the arithmetic there for me, please. With a calculator, give me a total.
Uh,
169 something.
Yeah, I was gonna say 169.9. I guess.
Well, keep going.
874.
Thank you. And this is grams per mole. Everyone see where we get this from? Again, you didn't have to do this to this problem, but if it did ask you to go to grams, now we're going to use that. Where is that going to go here?
On the top.
We're going to put the grams on the top. We're going to put 1 mole on the bottom. Mole and mole cancel out. Somebody do the math while I'm answering my phone, please. Mr. Brandon. Sure. Okay. Okay, thank you. Bye. Sherilyn, take your stuff, go down to attendance. What do we get here?
151.69.
Okay, so stop. 151.6. How many sig figs? 151.6.
That's 4.
I know. So the reason I'm stopping here is because I'm hoping you're going to tell me what does this number become. 152 grams of AgNO3. If you can find the moles, you can find the grams. Questions? All right. So, all the work is in there for you, ladies and gentlemen. I just was showing it to you there. All right. Our last one today, ladies and gentlemen, till I give you some time to work on some things. All right. How many milliliters of solution are necessary to have 12.5 grams of magnesium chlorate if the molarity of the solution is 0.250 molar? Okay. So what's the first thing we need to do with this problem, ladies and gentlemen? Somebody tell me.
Put grams into moles.
Okay, but even before that, I agree with you. We're going to need to put grams into moles. But before I can do that, I'm going to need to write what? I'm going to need to write my formula. You're jumping ahead just a little bit, Eric. You got the right thing, though. So, I need a formula for magnesium chlorate. All right? Somebody give me the symbol and the charge for magnesium. Mg plus 2. All right? Chlorate. Give me the formula, because it's a polyatomic, and the charge, please. ClO3 and -1. What would our final formula look like here, please, someone? Good. The 2 comes down by the ClO3. The 1 comes down by the magnesium. Because I'm putting a number by a group, I put it in parentheses. Okay. Now what do we need, Eric?
Formula.
Okay, we need the formula mass. So let's find the formula mass. Okay. 1 magnesium times 24.305. 304.
305.
Okay. 2 chlorines, 35.453. 6 oxygens. Add that all up. 95 and 96, about 191, somewhere in there. Somebody give me the actual number, please. I need your help, ladies and gentlemen.
I got 191.199.
Okay, that's good. That was about what I told you. 0.199?
Yeah.
And that is grams per mole, or grams equal to 1 mole, however you wish to express it. Okay? All right. So, I have to take the grams that I started out with. And I need to get it into moles. What goes on top? What goes on the bottom here?
191.199 goes on the bottom.
1 mole goes on the top. So take 12.5 divided by 191.199. Going to be a fairly small number, ladies and gentlemen. 0.0 something.
0.0654.
And again, here you don't have to worry about sig figs. I would carry at least 3, but you don't have to worry about it. It's not your final answer. Okay? So now, ladies and gentlemen, now we are going to plug things into this formula. Where does this go?
That would go on the top, like the mole.
Left or right?
Right.
Okay? Okay? So I got to have either here or here. Which one do I got? Read the problem and tell me which one I have.
The molarity, so on the left.
Okay, so what number goes here?
0.250.
What goes here?
The liters.
Liters. Okay? Now, we solve it. Okay? Now, I did talk to a math teacher the other day. I talked to Mr. G. I said, man, I am struggling to get some of my students, this is more my Chem 1 kids, Chem A, to understand what to do when we got this number on the bottom. And he said he shows them how to do it, but then he tells them to just do what with this to get to be able to solve for L. Anybody ever have Mr. G for math? Yes. So what does he tell you to do with this problem? See if you remember.
Maybe I think you have to say put it over 1. on the 0.2.
You could, but that's more Miss Grams and Miss Borley.
Oh.
He says he tells you to just do this. Switch those two. Switch those two. Now, why? Well, because if you have molarity equals moles over liters, take this side times liters and this side times liters. That's liters times molarity equals mole, right? Then divide M to get liters alone. So, he's right. All we're doing is switching those two spots. That's all we're doing in this case because it's on the bottom. Which means liters equals 0.0654 moles divided by 0.250 molar. Somebody do the math. Is that rounded?
Yeah.
Okay, what unit is that in? No, what unit should it be in right now?
All liters.
Liters. They want the answer in. So how do I get that to milliliters?
Just times it by 1,000.
Gonna take it times 1,000. If you can do that in your head, do that in your head. You need a calculator? Calculator. There's your final answer. Questions? Okay. Come up, grab a sheet of scratch paper. Okay. You may want to keep your computers open, but you don't have to. Come up and grab a sheet of scratch paper though. We got 9 minutes. Let's see if we can get one more problem done, ladies and gentlemen. All right, here's your question, ladies and gentlemen. Find me the molarity of a solution with 85 grams of NaNO3 and 750 milliliters of water. By the way, the decimal is after the 750 to give us what? Why did I put the decimal after the 0 in 750 milliliters? To make it 3 sig figs. So your answer will be in? Good.
Wait, can you erase some of the...
Oh my gosh, yes. Sorry, I forgot I was writing on the board today. What are we finding? What do we need? Moles and liters. Give me moles, get me liters. We can then find molarity. I'm sorry? Thank you. What's this going to look like here, ladies and gentlemen?
84.994 grams on the bottom and 1 mole.
So our answer is going to be just a little bit bigger than 1 mole. 1.0 what?
Yeah, I was just
1.00? Okay. So to find molarity, it is equal to the moles over how many liters of solution?
0.7 liters.
Remember, we need to convert this into liters. So what does the molarity become?
1.39.
There you go, ladies and gentlemen. Tomorrow we will give you a bunch of practice on this right at the start of class. Be ready. I'm sorry. When will we do that? Tuesday, because you guys got a nice long 4-day weekend coming up. Again, if anyone had any problems with their test, Yaneli, please make sure you leave it with me so I can correct that for you. Okay, what's wrong with it? Because that's not right. Just because it doesn't measure in Celsius, that doesn't tell me why we measure in Kelvin. You needed to tell me because the relationship doesn't hold in Celsius or something along those lines. It's okay. You'll get better at it, sir. Have a good day. Thank you, Yaneli. Thank you, Yaneli. That was the only one? Okay. I will add that point on there for you, not a problem.